All right, lesson 3-7. We are almost at the end of unit 3 already. Happily, it has no vocabulary, and as you can see, we're sort of going to skip over number 1. Before we get to it, though, there are two things that I want to go over. This section is on absolute value equations and on absolute value inequalities. An absolute value equation, this a here is substituting for any kind of phrase. It could be 3x minus 2. As long as it's inside the absolute value signs, it could be anything. The absolute value of something on one side equals b means that you have to solve two things. You have to solve the equation for a equals b, and you have to solve the equation for a equals the opposite of b. Because remember, the absolute value signs stand for distance from 0 on the number line. And there are two things with that distance from 0 on the number line: positive and negative. That one's pretty straightforward. It gets a little bit trickier when you're looking at inequalities. The absolute value of any expression is less than b means you're going to solve the compound inequality. The opposite of b is less than a is less than b. The absolute value of anything is greater than b means your compound inequality uses an or. A is less than the opposite of b, or a is greater than b. We're going to go over this in a little more detail as we work through this, but I wanted you to have the main points up front. Turn to page 207. This is the one I couldn't even bring myself to have you write down. There are two solutions for the absolute value of n minus 5 equals negative 2. I expect by now you can do this in your head. Add 5 to each side. Absolute value of n is equal to 3. So that means that n could be equal to one of two things, either 3 or negative 3. And all they wanted was for you to figure that out, plot it on a number line. Don't bother to write it in your book. Let's just turn the page. So problem 2 in your book is another multiple choice. You know how much I don't like those. So I'm just moving on to got it number 2, which looks like this. The absolute value of 3x minus 1 equals 8. So according to that rule that I gave you when we first started this, it means that you have to solve two problems. 3x minus 1 equals 8, and 3x minus 1 equals the opposite of 8. So you're going to go through both of those, and you should end up with x could be equal to 3, or x could be equal to 7/3. Now they asked you to check your answers. So check both of them. They should both work. 3, I didn't even do any more math than that. There we go. Absolute value of 9 minus 1 equals 8. Yes, it does. Now what happens over here? Check out 3 times negative 7/3 minus 1 equals, and I started to put negative 8, but that was not the original problem. The original problem was 8. You want to substitute both your answers in for the original problem. Negative 7 minus 1 absolute value, yes, equals 8. So problem 3 goes on to talk about impossible absolute value problems. I'm not sure why they would give you something like this, but if the absolute value is supposed to be equal to a negative, that just can't be. There is no solution. Remember, absolute value is a distance from 0 on the number line. There is no such thing as a negative distance. So that's a bit of a giveaway, I think, if there's no solution to this, because it's in the section on no solution. So don't worry about it. Move on to number 4. So before we start number 4, there's actually this super handy chart that's in the margin of my teacher book, and I'm going to give it to you right now. I would like you to pause the video and just copy this down in your book so that you have a reference. These are, it's a little bit hard to see perhaps, but these are absolute value signs. And it's just showing you, if this is the format of your problem, your thing in the absolute value signs less than b, then these are the two problems you have to solve. If it's the thing in the absolute values greater than b, these are the two problems you have to solve. It's an or. Similarly with less than or equal to, and with greater than or equal to. So this side is what you're going to match your problem up to. This side shows you how you're going to solve that problem. get it in your notebooks. So problem 4, they actually put this into practice. They've got something with the absolute value signs greater than or equal to 24. If you look back at the chart, it would say that means you need to solve the compound inequality this or that. There's the solution, and that's what the graph looks like. You are going to try it yourself on the top of page 210. All right, here's the problem they gave you, and then, honestly, I just went to that chart. It means I'm solving these two problems, this or that. And actually, best thing to do would be for you to go ahead and solve this yourself right now. I'll wait. Okay, now that you're done, your answers ought to look something like this. This is x is greater than or equal to 1/2, or x is less than or equal to -9/2. And you could go ahead and graph that. Problem 5 is one of those trying to make your math practical kind of problems. We've got boxes of crackers that are supposed to weigh 213 grams. There's an inspector who's looking to make sure that it doesn't differ more than 5 grams. But that means it could be 5 grams above or 5 grams below. And here is a problem to figure out what the weight might be. The smallest it could be is 208 grams. The biggest it could be is 218 grams. Got it number 5 asks you to do exactly the same problem again with boxes of pasta. Don't skip it. Skip 5A. I want you instead to think really hard about 5B, because that might make some of this more clear to you. Could you have solved the inequality, the absolute value of W minus 213 is less than or equal to 5, by first adding 213 to each side? And this, I want you to think about, test it out, then come back and we'll chat. So, I'm hoping you figured out that if you had decided to ignore the absolute value signs and just add 213 to each side, you would have ended up with only half an answer. W less than or equal to 218. You would have completely been missing that part of your answer. So that's why you have to leave these absolute value signs intact. That's why we have to do, the other stuff, turn it into a compound inequality and solve it that way. The rest of your work for this amazingly short video is the lesson check, page 210, all 8 problems. Have fun!